Welcome back, ladies and gentlemen. In this video, we are continuing our discussion on triangle congruence. So far, at this point in time in our curriculum, we know how to prove triangles are congruent by two things. One, we can prove that all of the corresponding parts are congruent, thus, of course, makes the two triangles congruent. And then we've also learned about side, angle, side congruency, where we showed that the two sides and the included angle are congruent on two different triangles, and that's enough information to prove that the two triangles are congruent. But I told you that there was 5 congruency theorems that we are going to be talking about, and in these next few videos we're going to discuss 2 more, known as side, 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 and the hypotenuse leg theorem. For this video specifically, we are going to be using side, side, side congruency theorem. We will define what side, side, side congruency theorem is all about, and we will use it in proof to show how triangles are congruent. So let's dive right on in. Side, side, side. What are you thinking? If side, angle, side was 2 sides and the angle sandwiched in between, side, side, side is that, hey, if you can show that all 3 sides of 2 different triangles are correspondingly congruent, that's enough information to prove that the 2 triangles are congruent. And you think about it, again, common sense kind of tells us, well, of course, if the 3 sides of a triangle are congruent, that's what kind of makes a congruent triangle congruent. Then we talked about in chapter 4 are transformations. A dilation keeps the same angle measures, but it changes the side length. And so that's how we get similar triangles. But when we have congruent triangles, those sides are exactly the same. Remember, I can map one triangle directly onto the next. And I can show that by simply showing that the 3 sides of 2 triangles are congruent. So let's take a look at our first proof. Diving right on in. We want to go ahead and prove that these 2 triangles, KLM and NLM, are congruent. And we're given that KL is congruent to LN, and we are given that KM is congruent to NM. Now the goal is to be able to use, like I said, the goal of this proof is to use side, side, side. So let's talk about that third side. Where is it even coming from? Well, go back to our number 1 and number 2 look-fors that we have for proving triangles congruent. My number 1 is look for shared sides. Number 2, vertical angles. Number 1, I see shared sides right here. LM is congruent to itself in this diagram. So use it to your advantage. So side, side, side. Boom. Game, set, match. Let's put it into proof. I'm given that KL is congruent to NL. That's given to us. That's one side. That's my S's right here. That's one side. I'm given that KM is congruent to NM. There's side number 2. I just said that they share a side of LM being congruent to one another. So if that's the case, remember that's our reflexive property when it looks exactly like itself on the other side of the congruency symbol or the equal sign. If I look in the mirror, so there is our reflexive property. LM is congruent to LM by the reflexive property of congruence. And you may be asking, well, Mr. Guggen, why again? Sometimes you switch these and sometimes you don't, the order. Again, I'm not switching them in this case because L is in the same position in both triangles. Angle L is in between NL and ML in both cases, KL and ML. It's in that same corresponding position as they would. The 2 triangles KLM is congruent to NLM in side, side, side congruency theorem. All right, so there's a prime example of how we can use side, side, side. Let's go ahead and try to use one more. So in this example here, we have LM being congruent to NP. So I'm going to go ahead and just kind of start right off the bat with what we know, all right? So our statements on this left-hand side, we know that LM is congruent to NP, and that is given to us. So again, it's on the left-hand side. I'm just going to put an S here for side, just so we kind of know that where side's coming from. We also are given that LP is congruent to NM. And again, that's given to us. So I'm going to go ahead and just put side here just to help us out and find out which one's our next one. Well, again, guys, don't try to reinvent the wheel. Right off the bat, you see another shared side. Use it to your advantage. Reflexive property. So I can say that NL is congruent to LN. Reflexive property of congruence. Okay? So again, let's talk about this. Why do I keep changing the order sometimes, and why not? Because again, the corresponding angles have to match up. If you notice, N to L, right? N is in a position that is in between PN and LN in this case, or the single tick mark and the triple tick mark. So that means that L on this triangle is in between the single tick mark and the triple tick mark. So the N in my first triangle has to match up with the L in my second triangle, and then vice versa. L in my first triangle has to match up with my N in my second triangle. Thus, I can say that the two triangles LMN and NPL are congruent by side-side-side congruence theorem. Okay? All right, ladies and gentlemen, on to the next one.